Good day. Welcome to another chemistry session. Today we will be looking at the topic balancing complex redox reaction. Introduction. You have learned about reduction and oxidation in some previous lesson. Objective. At the end of this lesson, the student will be able to balance redox reaction involving oxidizing agent in alkaline or acidic medium. Describe the step involved in balancing complex reaction. 3. To state the order of balancing in both acidic and basic medium. Now, balancing complex redox reaction in acidic medium. The word acidic means that there is presence of hydrogen ion. Most oxidizing agents work best in acidic medium. Hence, hydrogen ion must be added in order to balance the equation. An example is given below. Ion 2 plus manganese MnO4 minus to give ion 3 plus Mn2 plus. In this case, we are asked to balance in acidic medium. Step 1. Divide the equation into two half-cell reactions. The first one now will now be ion 2 to ion 3. The oxidation number for ion 2 is plus 2 and for ion 3 is plus 3. Now for the second equation, half equation, it will be MnO4 to Mn2 plus. The oxidation number of manganese will be from plus 7 and on the reactant side it is plus 2. Then we will see that both equations are not balanced atomically and ionically. Now step 2 now. Balance the two equations molecularly and ionically. Now, for ion 2 going to ion 3, since we have one atoms each, so we have for one atom of ion on the reactant side and one atom of ion on the product side. Now, the oxidation number is plus 2 and for ion 3 is plus 3. So, we need to add electron minus to balance it up so that the net charge will now be plus 2 on the reactant side and plus 2 on the product side. Now, in the case of equation 2, which is MnO4 minus to Mn2 plus, now we found out here that there is no oxygen on the product side. So we need to account for the oxygen here because permanganate is an oxidizing agent, and also to account for the oxygen on the reactant side, we introduce hydrogen ion. Thus, this equation becomes MnO4 minus plus H plus to give us Mn2 plus plus water. And so this becomes our equation 4. Then we balance both atomically and ionically. Therefore, we are now going to have MnO4 minus plus 8 moles of H plus to give us Mn2 plus, that is 1 mole of Mn2 plus, plus 4 moles of water. And so when you consider the oxidation number on the reactant side, the net charge there will be plus 7. Why? Because MnO4 is minus 1 and 8 hydrogen ion is plus 8. So minus 1 plus 8 will give us plus 7. And on the product side, we have Mn2 plus plus 4 molecules of water. So for Mn2 plus is 2 plus, and for water is 0, and on the reactant side is plus 2. So we see that this one is not balanced ionically but atomically balanced. So to balance it ionically, we add 5 electrons to the reactant side in order to balance to the smallest charge, which is plus 2. Then equation 4 will then become MnO4 minus plus 8 hydrogen ion plus 5 electrons to give us Mn2 plus plus 4 molecules of water. So when you consider the oxidation number, for MnO4 is minus 1, for 8 hydrogen ion is plus 8, and the 5 electron minus is minus 5. Then on the product side, we have Mn2 plus is plus 2, and for the 4 water molecules is 0. And so you find out that for the reactant side, it is plus 2, and for the product side, it is plus 2. So both reactions are now balanced atomically and molecularly. So we'll stop there. Thank you. I'll see you again. Now, welcome back. Now, we continue where we stopped. We stopped at step 2. Now, we go to step 3 now. Now, in step 3, we'll match the equation to cancel out the electrons. Now, since we are looking for a balanced redox reaction, we match the two equations together, that is equation 3 and 5, but the electrons are not the same. The electron is made same by multiplying equation 3 by 5 and equation 5 by 1. And so equation 3 then becomes 5, that is F2, Fe2 plus to Fe3 plus E minus, multiply all by 5. And equation 5, you multiply by 1, which is MnO4 minus plus 8 hydrogen ion plus 5 electron minus to give us Mn2 plus 4 molecules of water. You multiply that by 1. Thus, the two equations then becomes 5 ion 2 to 5 ion 3 plus 5 electrons and MnO4 minus plus 8 hydrogen ions plus 5 electron minus to give us Mn2 plus 4 moles of water. Merging this together, we now have 5 Fe2 plus MnO4 minus plus 8 hydrogen ions to give us 5 Fe3 plus Mn2 plus 4 moles of water plus 5 electrons. Now, since the two 5 electrons are on both sides, that is the reactant and the product side, so they cancel out. So the net oxidation number or the net charge for both the reactant side and the product side will be plus 17. Now, for the reactant side, we are going to have plus 10 minus 1 plus 8. That gives us plus 17. And on the product side, we have plus 15 plus 2 and plus 0. And that gives us plus 17. Therefore, the balance equation in acidic medium thus becomes 5 ion 2 plus MnO4 minus plus 8 hydrogen ion to give us 5 Fe3 plus Mn2 plus 4 moles of water. Note, it is not all the time that the hydrogen ion will be on the reactant side. Sometimes it could be on the product side. For example, if you are to balance SO2 plus ion 3 plus to give Fe2 plus SO42 minus. Following the steps outlined above, we have Fe3 to Fe2. So the oxidation number is plus 3 on the reactant side and plus 2 on the product side. Balance equation becomes Fe3 plus electron minus to give us Fe2 plus. So for the other equation, it will be SO2 to SO42 minus. Here, you will find out that oxygen atoms increases from 2 atoms on the reactant side to 4 atoms on the product side. Hydrogen ions cannot be responsible for it here. Water contains oxygen. Therefore, water, that is H2O, is added in this case, and hydrogen ion balance on the product side. Thus, we have SO2 plus H2O to give us SO42 minus plus hydrogen ion. By balancing it atomically, we have SO2 gas plus 2 hydrogen plus 2 molecules of water to give us SO42 minus plus 4 hydrogen ion. Oxidation number wise, now SO2 we have 0, water we also have 0, that is 2 times 0. Then SO42 minus we have minus 2, and 4 hydrogen ions we have 4 times plus 1. So the net charge will now be 0 on the reactant side and minus 2 plus 4 on the product side. Balance the charge to the smallest value, which is 0. So you are now going to have that. So in order to eliminate the electron, we make sure that it balances at both sides. So we multiply the ion equation by 2 and that of the SO2 equation by 1, thus giving us 2 molecules of ion 3 plus 2 electron minus to give us 2 molecules of ion 2 ion. Now SO2 still remains the same. Therefore, the balanced equation thus become 2 ion 3 plus SO2 plus 2 moles of water to give us 2 moles of ion 2 plus 1 mole of SO42 minus plus 4 hydrogen ion. The net charge on both sides becomes plus 6. Hence, the balanced equation is what we are having. Thank you. I will see you again. Welcome back to the final session. Now here we want to see how we can balance in alkaline medium. Now to balance in alkaline medium, there are two ways. One, by balancing from a balanced equation in acidic medium, or by balancing directly using OH minus to either side where applicable and balance with water. Now the first one we take from acidic medium. Now in acidic medium, from acidic medium we have add the same number of moles of OH minus as that of hydrogen plus present in either side of the reaction, e.g. from the two given balanced equation where we have 5 moles of ion 2 plus MnO4 minus plus 8 hydrogen ion to give us 5 moles of ion 3 plus Mn2 plus 4 moles of water. So we now have, thus in alkaline medium, for that we now be 5 moles of ion 2 plus MnO4 plus 8 hydrogen ion plus 8 OH minus to give 5 ion 3 ion plus Mn2 plus 4 H2O plus 8 OH minus. So we add 8 OH minus to both sides. Now, since hydrogen ion and OH minus will give water, therefore 8 hydrogen ion plus 8 OH minus to give us 8 hydrogen ion. So the equation becomes 5 moles of ion 2 plus 5 plus manganate ion, that is MnO4 minus, plus 8 moles of water to give 5 ion 3 plus 1 mole of ion 2, manganate 2 plus 4 hydrogen plus 4 moles of water plus 8 OH minus. Now find the net number of moles of water on both sides. So you now have that you are having more of the water on the reactant side, and so the number of moles of water will be on the reactant side. Therefore, having a balanced equation as 5 moles of ion 2 plus 1 mole of MnO4 minus plus 4 moles of water to give us 5 moles of ion 3 plus 1 mole of Mn2 plus 8 moles of OH minus. And so by the time you look at the net charge, you'll find out that plus 9 on the reactant side and plus 9 on the product side. Likewise to the second equation as well. Likewise to the second balanced equation from acidic medium, which is 2Fe3 plus SO2 plus 2H2O to give us 2 ion 2 plus SO42 minus plus 4 moles of hydrogen ion. So we add 4 moles of OH minus to both sides, and so by adding it to both sides, so what are we going? So we are now going to have Fe3 plus SO42 plus SO2 plus 2 moles of water plus 4 OH minus to give us 2 ion 2 ion plus SO42 minus plus 4 moles of water. So we net out the water, and the balanced equation becomes 2Fe3 plus SO2 plus 4 OH minus to give us 2Fe2 plus SO42 minus plus 2 moles of water. Number 2, now balancing direct with OH. You can balance by adding OH directly to either reactant or product side where applicable. Now, if you are adding OH on the reactant side, you add water to the product side. If you are adding water to the reactant side, you add OH on the reactant side. In a nutshell, balancing of complex redox reaction is summarized below. Now, if hydrogen ion is added to the reactant side, water balances it on the product side. If it is water on the reactant side, hydrogen balances it on the product side. That is for acidic medium. In the case of basic medium, you have OH on the reactant side, water on the product side, water on the reactant side, OH minus on the reactant side. Now I want you to try this. Balance this equation. MnO4 minus plus SO3 2 minus to give SO4 2 minus plus Mn2 plus. I'll take it again. MnO4 minus plus SO3 2 minus to give SO4 2 minus plus Mn2 plus in basic medium. Thank you. I'll see you again. Make sure you are safe and God bless you.